Hey guys, it's Mr. C, and in this video I'm going to show you how to solve parts A and B of the second example, the section 4.1 note sheet. This is the very bottom example of page 1, and here we have two functions provided for us. However, they're provided to us in the graphical setting versus an equation setting, and yet we're to answer some questions about it. In part A, we're going to be answering, f of x is equal to g of x, and in part B, we're going to be solving an inequality. All right, so the skill here is a little bit different than the one with the example prior to this. Part of the reason being that we don't have the equation for each of the functions, but there are some things that we can infer about the equation of each of these functions. First of all, here's the graph of f of x, and that appears to be a line. So, we could assume that f of x is some sort of linear function. It's also crossing the y-axis at what appears to be a positive value, so it'd have a positive b value. And also, the line is slanted upward, meaning that its slope would be positive. All right, so a linear function with a positive slope and a positive y-intercept. Now, with the function g of x graph, that also is a line, so g of x can be assumed to be a linear function. It does cross the y-axis at a positive y value, so a positive b value. But this time the line is slanted downward going from left to right, so the slope of g of x would be negative. All right, and that's about the most we can infer about the equations for both of the functions. But how do we solve something like f of x is equal to g of x if we're just given the graph of the two functions versus the equations? Well, you're probably seeing it glaring right at you. This point right here is a point of intersection, and it happens to be a point that's both on the graph of f of x and g of x. Now, the ordered pair is spelled out for us, and that is 2, 5. So conceptually, this means that when x is 2, both f of x and g of x are going to have the same y value of 5. All right. In the context of functions, f of 2 is 5, and also g of 2 is equal to 5. So, for example, part A, they want us to figure out, what's the value of x that makes the output of both functions the same value. So the key here is to look for a point of intersection. All right, and that's something I'd like us to note with this. Look for a point of intersection. And of course, that point of intersection is at 2, 5. Ultimately, when we provide an answer for something like f of x is equal to g of x, our answer is going to be a value of x. Okay, and that value of x is going to be 2 because that's the x coordinate of the point of intersection. So x equals 2 is our answer to that. Moving on to part B, we now have an inequality that we need to solve. We need to solve f of x is greater than g of x. And so if you watched the last video, I mentioned that how you interpret the inequality symbol from the diagram standpoint is as follows. If the inequality symbol is greater than, you want to look for parts of the graph of f of x that are above the parts of g of x. And there's even a little side note here. The first point is f of x is greater than g of x, and that means is look for parts of the graph of f of x that are above the graph of g of x. Whereas if the inequality symbol were reversed, we would be looking for parts of the graph of f of x that are below g of x. The point of intersection is actually going to be helpful for us on this regard, because if you look to the left of point of intersection, this piece of graph right here is a piece of the graph of g of x. And visually, this piece of the graph of g of x happens to be above a part of the graph of f of x. And so it just so turns out that it's unfortunately not a part of the diagram that we're interested in. All right, so we're not going to be concerning ourselves with anything in this diagram that's to the left of the point of intersection here, because to the left of the point of intersection we're seeing parts of the graph of g of x being above f of x, whereas we want the opposite case. So that leads us to look to the right of the point of intersection. To the right of the point of intersection, that's when we start to see the graph of f of x being visually above the graph of g of x. Alright, so this piece of f of x right here is something we're interested in. This is a part of the graph of f of x that is above the graph of g of x. From an input-output standpoint, what we're trying to accomplish here is figuring out, what inputs make the outputs of f of x larger than the outputs of g of x. But it's much easier to kind of think of it in terms of what part of the graph of f of x is above g of x. And that happens to the right of the point of intersection. What we should do next is label the x-axis with the x-coordinate of the point of intersection, because our answers are actually going to come from the x-axis here. It's kind of like a phase 2 in a two-phase process. Alright, so to get our official answers here, we need to figure out what are the values of x that correspond to this piece. And those values of x would be between positive 2 and go all the way up to positive infinity. Now note that there is no bar underneath here, so if you wanted to whip up interval notation, which is something we're going to do, you'd want to use a parenthesis. Alright, so on this diagram I'm going to place a parenthesis opening towards the direction of shading at the x value of 2. And as soon as we whip up interval notation for this part of the x-axis, our problem is done. So without further ado, here's our answer to part B, parentheses 2, comma, infinity. Okay, that's a wrap for this example. As always, let me know if you have any questions. Otherwise, thanks for watching. I'll see you next time.